This video, I'm going to do 4 additional examples of solving right triangles using trigonometry. So we have to make sure we're using our SOHCAHTOA sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. We also have to make sure that our calculator is in fact in degree mode. So I can check that by going to mode and making sure that my degree, the word degree, is highlighted. Since it is, that means it is in degree mode. First example, so I'm actually going to call this number 9 because the last video I had 1 through 8. Number 9, I'm going to have a triangle. I'm going to draw a figure. I'm going to make it a right triangle. I'm going to have my x degrees right up there. I'm going to have a 7 on the side. I'm going to have an 18 right here. So on this one, we have to make sure that we highlight our hypotenuse. Hypotenuse is across from the right angle. And then we label our triangle with all the stuff that we have. So our theta goes where that x degree is. The 7 is attached to that theta but not highlighted. That's our A. That's the adjacent. The 18 is on the highlight, so that's automatically H. So A and H together is the cosine. So we have cosine of theta is equal to the adjacent over the hypotenuse. So then I have cosine of our theta is that x equals the adjacent was the 7 over the hypotenuse is the 18. Since x is in the parentheses, we have to do the inverse. So we have cosine inverse of the fraction is 7 over 18 is equal to what our theta is, our x. So I'll do second cosine, 7 divided by 18. And it's roughly 67 1/10 degree. So x is approximately 67 1/10 degree. Number 10, I'm going to put it beside it. I'm going to draw a figure. Put a right angle. I have a 39 degrees down here. I have an x on the side. And I have a 6 2/10 up top. So I'm going to, first thing I'm going to do is highlight what looks like the hypotenuse. It looks like the hypotenuse. Then I'm going to label the triangle. So I have theta is at that 39 degrees. I have that 6 2/10 is across the triangle. So that's our O, that's our opposite. And the x is attached to that theta, but it's not highlighted, so that's our A, adjacent. So O and A together is tangent, O and A together. So we have tangent of theta is equal to opposite over the adjacent. So we have tangent of our theta is the 39 equals our opposite is the 6 2/10 over the adjacent is the x. So you're given your numerator. If you're given the numerator, you take your numerator and divide it. So we have 6 2/10 divided by the trig. That's the tan of 39, and that will give you your x. So 6 2/10 divided by that tangent of 39 degrees, close parentheses, is roughly 7 7/10 degrees. So 7 7/10 degrees. So x is approximately 7 7/10 degrees. Number 11. Going to draw a figure. Going to put a right angle there. A 10 on what it looks like to be the hypotenuse, a 12 on the side, and an x degree up top. So we're going to highlight what looks to be the hypotenuse. We're going to label the triangle. So theta is where that x degree is. The 10 is on the highlight, so that should automatically be your hypotenuse. It should be your h. And then the 12 is attached to the theta, but not highlighted, so that's your a. So a and h, that's cosine. So we have cosine of theta is equal to the adjacent over the hypotenuse. So we have cosine of x is equal to your adjacent looks to be 12 and your hypotenuse looks to be 10. So if your x is in your parentheses, that means you're finding your angle. That's your inverse. So we have to do cosine inverse of the fraction of 12 over 10. That's supposed to give us our x. Now if we do this, second cosine, that's how you get the inverse. 12 divided by 10. We get an error. Why do we get an error? We didn't do this wrong. We set it up correctly. So why did we get an error? I want you to look back at the triangle. The hypotenuse, if we remember anything about the hypotenuse is always supposed to be the largest side, but the adjacent is 12 and the hypotenuse is 10. So we cannot actually do this problem because your hypotenuse is not the largest side. So this problem is actually not possible. This is not possible. The reason why is your leg is longer than your hypotenuse. Leg is longer than the hypotenuse. That means that we cannot do this problem. So if you notice that your leg is already longer than your hypotenuse, or if you notice that when you get an answer, your leg ends up being longer than your hypotenuse, you know you've done something wrong. Now your two legs can be longer than each other, that's fine, but your hypotenuse has to be the longest. So always check that. The last problem I'm going to do, draw a figure. I have 49 degrees up here. I have a right angle. I have 13 on this side, and I have x on this side. Going to highlight what appears to be the hypotenuse. Going to label the triangle. Theta is at that 49 degrees. The 13 is through the triangle, so that's going to be our opposite. And the x is on the highlight, so that should be our hypotenuse. So we have O and H. O and H is sine. So we have sine of theta is equal to opposite over hypotenuse. So we have sine of theta is 49 degrees is equal to your opposite is your 13 over the hypotenuse was the x. This time you're given your numerator. If you're given your numerator, you take your numerator and divide it by your trig. So 13 divided by your trig, which is sine of 49, is supposed to equal to x. So we have 13 divided by sine of 49 degrees, close your parentheses. We get 17 and 2/10. Now we're saying that the hypotenuse should be 17 and 2/10, which is larger than the 13, so that should be right. So x is approximately 17 and 2/10. So again, if you are given your numerator, you take your numerator and divide it by the trig. If you're given your denominator, you take your denominator and multiply it to the trig. If your x is inside the parentheses, you take the inverse of the trig.